This home has exterior shading, which allows it to capture sun during the daytime, and then when it's too hot, the shades will actually go down and keep the house cool. I'm here with Tim out at his house. He's the owner of TE Studios. We've got a sweet passive home, and he's going to show us how everything works. What is a passive house?
Passive house is a super efficient home or building of any sorts, really. It's built around super insulation, air tightness, passive solar heat gains if they're available, and has a heat recovery ventilator to keep the indoor air quality very, very high at all times. And if you do all those things in conjunction, you really lower the heating load and cooling load in our parts here in Minnesota, usually by about 90%. So it's a energy sipping building, we want to call it that. The shading is an integral part of a passive house, in particular in a heating-dominated climate like ours, just because the windows become practically a solar collector for the house in the winter time. And so the shades are, in one shape, form, or another, the thermostat for that system. The window glazing, in this case, is made to allow a maximum amount of solar heat to transfer to the inside. That's our free heat. And the shades basically can determine when it's enough. And in our case, they do a little bit more than that because they're not just opaque or open, but they can articulate and respond to the indoor and outdoor conditions and give us a maximum amount of daylighting in combination with the protection that we seek. So the shades want to be on the exterior of the building simply because all modern glass is formulated to lock in heat once it is transferred to the inside of the building. And so shading on the exterior will capture about 90% of the sun's power right there, so it doesn't even make it into the building. If we had interior blinds in this building, most of the heat would already be inside and would have to be air conditioned back. And so that's why these shades are on the exterior, just to have the maximum input. And maybe on a side note, we also use these for glare control and for privacy. So one of the features of our house is a very basic range hood that simply pulls out and recirculates the air. Because we have a whole house ventilation system, we don't exhaust the air from cooking. We bring it back in here, and our whole house ventilation system, which is located right above me, actually is the machine that takes the air to the outside. And we do that because the whole house system has a heat recovery in the actual ventilator, whereas a range hood would not. And also a passive house is an airtight building, so if we had a device that simply sucked on it, it wouldn't work because there's no opportunity for that air to be replaced. So that's a unique feature. And then to help make this all work seamlessly, we cook with electricity. We have an induction cooktop and an electric stove. It's an all-electric house. Really enjoyed the cooking on induction. It's extremely responsive. It doesn't put out a ton of heat into the space, which is good in a super insulated house. And it's safe. There's no flame. You can't burn yourself on it. So this is our passive house cooking arrangement. This black box here is a air-to-air heat pump. This unit provides us with hot and cold. It's all electric. There's an outdoor unit that feeds this indoor unit through these refrigerant lines. And this makes hot or cold from ambient air. So in the winter, it squeezes heat out of the outside air, even at -20 here in Minnesota, and makes heat. And in the summer, it rejects, like any air conditioner, warm air from the house to the outside. This unit is extremely efficient, very quiet. It is running full steam right now. And its maximum output is about 3.4 kilowatts. So that's equivalent to about 2 hair dryers going at the same time. And in our house with 2,100 square feet, that is our peak heat load here. So we can, on the coldest day of the year in Minnesota, heat the whole house with just that. It is controlled with a lock zone automation system that also controls the shades that you saw. There's a relay station here that we have connected to it. And that allows us to use the same sensors that we use for the shades and our weather station on the roof to build a certain body of intelligence that then decides when the machine needs to turn on for heating or cooling. The irony of modern construction in Minnesota and modern codes is that you need a 200 amp service and lots of breakers, which you can see here, even though this house sips energy at less than 1,000 kilowatt hours per month for a family of 4. But nonetheless, these are the breakers that we need to run it, and then we monitor the whole system with an E-gauge setup, which is in this box right here. So we can't show it at the moment, but this is where every circuit is recorded, and we can then see where energy is actually consumed. We can also see where PV is and when PV is generated on the roof and how those overlay. Here's the cell phone interface or the web interface, which shows the graph of energy consumption versus production. The green being production, the red being consumption, and anything that's white is when those two things overlay and coincide. On this side of the room here, we have our all-electric heat pump water heater. So this unit sucks air in from the space that we're in, runs it through a heat pump right here at the top of the machine, and squeezes heat out of that air and makes hot water for the tank down below. These contraptions that you see here is my attempt to quiet this machine down a little bit. This is fairly noisy when it runs. I can turn it on for you so you can hear that. And there we go. So typically it wouldn't come with these attachments, but that's just something that's homemade because in our house the mechanicals are on display. This is extremely energy efficient simply because it pulls room air at about 70 degrees, and from there it's very easy for the heat pump to generate hot water. For a family of 4, we only use about 2 kilowatt hours of electricity per day to do that, so less than 30 cents. In conjunction with this whole setup, we also run in the pipe back here that is fully insulated a wastewater heat recovery unit, which is essentially a plumbing pipe made from copper with the fresh water line wrapped around it. And so what this system does is every time we take a shower upstairs and hot water runs down this drain to the city sewer, the cold water coming into the house and going to the hot water heater is pre-warmed in this pipe by virtue of it looping around the warm affluent. And that lessens the burden for the hot water heater by about 30%. So it makes it more efficient than it would be otherwise, because it just gets fed warmer water than the city would typically give us out of the ground.
So of course people are going to ask, what's the cost difference between a water heater like this and this unit compared to like a furnace?
I have no idea.
All right,
because there are so many factors that come into play.
Yeah.
The cost difference in what? In buying the machine, in buying the machine plus install, in buying the machine plus install plus operating it for 5 years, 10 years, 15 years. What costs are we talking about? Right?
I would think the upfront cost of the equipment and the installation.
And the simple answer is upfront cost is completely irrelevant, because that's not how you pay for a house. It's total cost of ownership. So if you want to be a good steward of your money, that's the only thing that matters. What's your all-in cost over a given time frame that you find acceptable? And I think that's where our whole society needs to shift its thinking. That's how EVs are being sold and many other technologies are being sold. You have to look at the efficiencies that this produces downstream. We're working with LockZone as a controls partner, as I mentioned, for the shades. As well as a thermostat control, and we do have an irrigation system that's controlled by their system. And one of the components of that system are these touch buttons or switches and sensors. This is one of the nicer models that they make. It's got a glass surface, and you can see there are essentially 5 hot zones marked out in this, and then there's a center section. And you can program this to do basically anything you want. It could play music or dim the lights, but in our case, we use it predominantly for shade control. So we have different zones of shades up and down on these buttons. We have auto shading in the middle. If I hit that, it'll respond to the weather and adjust itself. And then also we have a thermostat and a humidistat in each one of these. And so this takes a reading of the conditions inside of our great room here and feeds it back to the central unit, which can then decide whether we need to heat, cool, drop the shades, any of those things. This system is completely universal. It can do many things, but that's how we use it in our house. And you will see these not just here in the great room, but also in every bedroom is where we use them. Part of making a custom home is you need to have a little bit of fun too and create some interesting spaces. And for us, we wanted to have a little bit of a vertical space in the house, and we actually have 2. There's one at our front entry, and then there's the one here in the heart of the building. And we have this little balcony area, which started out in life as a reading nook, perhaps, and now is exactly the opposite, with my other daughter being a drummer, having her drum set up there. in-house ventilation here in our passive house. It's a key component, a core component of any passive house, meaning it's balanced, air is put into the home and it's exhausted back out at the same rate. So there's not an over or under pressurization. And the heat recovery ventilator, the machine that facilitates that, has a core in the middle where these air streams bypass each other. And at the core, we exchange temperature and humidity at a certain rate so that in the winter, the outside air coming in is passively preheated, and in the summer, it's passively pre-cooled. Every living space and bedroom in the house has a supply, such as the one right above me here. And these supplies serve the purpose of bringing that fresh, filtered outside air to the living space. And then in the kitchen and bathrooms, we have similar looking air exhaust intakes that take the stale air from the house, collect it, and bring it back to the outside. And this happens at the same rate as if we were opening all our windows in the house every 30 minutes for 10 minutes or so. And in Minnesota, that's just not realistic because our weather doesn't allow for that. It's too hot, too humid, too cold, too dry. And so this system is perfect because it basically eliminates all of that. We don't have to think about it. We just get fresh filtered outside air all day and all night. And the heat recovery efficiency of this system is about 85% all in. So it takes very little additional heating or cooling to modify the temperature of that air coming into the space. This is a utility room in the sense that laundry, ironing, clothes drying, and our ventilation happen here. So for all intents and purposes, this is a really functional space for us in this footprint, and we made it such on purpose. So this is the heart of our mechanics, the ventilation system right here. This is the machine that brings fresh air through the house all day, all night with heat recovery. If you look at the box itself, I'll close this up for a second, that's the actual heat recovery ventilator. We have an exhaust, an intake that's sort of hidden behind it, and then we have a whole house piped system with a supply and return right on top. They're stacked one behind the other, so you can only see right now one of the two sets. And so inside the machine, the airstream crosses. There's the heat recovery core in here that manages the heat transfer and energy transfer, and then the filtration on top. And just earlier today, I took a filter out that is maybe a couple of months old, just to illustrate all the things that we didn't breathe and get into the house right here, which if you do window ventilation, obviously you don't get any of these benefits. And we had a discussion about that earlier today, that last year when we had a lot of wildfires, these filters would come out pitch black. So all the soot would be filtered out of the air. You couldn't smell the wildfire in the house at all. It was all captured and taken out with these filters that live right up in here. So there's one for the airstream from the outside, and then there's one for the return from the house. And that's just there to keep any debris from the house from mucking up the heat exchanger core. This runs all the time. My heating and cooling runs 3 months, 4 months out of the year. This is on all day, all night. The noise that you hear coming off of it is it running at full steam right now. So this is the maximum noise it will ever make.
It runs 24/7.
That's correct. So another LockZone touch controller here. This one also measures temperature, relative humidity, and also allows us to modify what the shades are doing. So in this case, I just sent them up, and they're now obeying my command and going up.
Thanks so much for watching. I hope you guys enjoyed this video. If you did, be sure to check out this video right here. I think you'll love it. It's a net zero home right here in Minneapolis, and it's very affordable. So be sure to check it out. Thanks.